Okay, next we're going to talk about how you draw angles in what's referred to as standard position. Standard position means that the angle is always measured from the positive x-axis. So in these three cases I have drawings of different angles, and all of them are measured from the positive x-axis. Now, depending on whether it's a positive or negative angle depends on the way that we're going to draw it. This first one here, positive angle means that you're going to be drawing it counterclockwise, which means it goes around this direction. So it's still going to be measured from the positive x-axis, but it's going to go around that way. It's going to go to that way to the left, counterclockwise. If you have a negative angle, then it actually goes clockwise around. By the way, this symbol right here, this is our Greek letter theta, and that's what we use to indicate an angle. That's the most standard symbol that's used to represent an angle. We have theta there. So positive angles go clockwise or counterclockwise, and you have negative angles, they go this direction. So you're actually going to start by going down. Now notice that this angle and this angle, they look like they're the same measurement. So actually there's two different ways that you can get to it. You can either go around the positive direction, so we're going to go around counterclockwise for that, or we're going to go around this direction, we're going to go clockwise to get to it. So either way, you're going to arrive at the same angle regardless. But there's different ways of indicating that depending on whether it's a positive angle or a negative angle. Then we have this here. Now this, if you have an angle that's more than 360 or more than 2 pi, depending on what you're using for your angle measurement, you kind of have a spiral happening here. It's going to go around once to here, and then you're going to go around a little bit more to your same angle there. So again, all these here would end up at the same spot. We're just going about it a couple different ways. So this goes around once and then goes around again. So anytime you have more than 360, you have the spiral thing, and you could go around once and twice and you just keep going around with the spiral until you get to the angle there. Also, we have to know about quadrants. We have to know kind of how angles are drawn, because the problems that we're going to do right after this in this video will have to do with drawing angles in standard position. So angles start at 0 degrees, and then it goes to 90, 180, 270, and back around to 360 again. And for review, here are the different quadrants that are labeled, because sometimes these questions might ask you what quadrant does the angle end up in. And those are the types of problems we'll look at next. In order to know that, we have to know that the first quadrant's 1 here, and it goes around counterclockwise. So we go 1, 2, 3, 4 all the way around in that direction. Here it is with radians. Starts out at 0 radians, then you got pi over 2, pi, 3 pi over 2 down here, and back around to 0. The reason why you want to know what these measurements are is because that way you know what quadrant to draw them in. So if we have an angle of let's say 120 degrees, we would know that 120 is between 90 and 180, we would know it would go in here. If you're talking about radians, then you have to look at the fraction. So you look at some kind of fraction, you'd see if the fraction goes between 1/2 and 1, or 1 and 3/2, and so forth, and you can kind of draw it out doing it that way. So we'll take a look at some examples now where we're drawing in standard position. Okay, so now we're going to get into drawing angles in standard position. So here's 3 that we're going to do, parts A, B, C. Asked each of us to each of these we want to draw in standard position, and then indicate the quadrant that it lies in. Okay, now if you're not familiar with radian measurement right away and haven't done much with it, we can always convert this back over into degrees. We can draw it in standard position in degrees. So that's what we're going to do on this one. The 5 pi over 6, we want to change that into a degree measurement. So to do that, we're going to multiply this by 180 over pi. We talked about that before, how you convert from radians into degrees. That's your conversion factor we're going to use here. The pi's are going to cancel, so we cancel those out. 6 goes into 180 30 times, which means that you get 150 degrees as a result. What we just talked about was how to know where to draw your angle. So in the previous video I mentioned right before this, I said that this is 0, 90, 180. So 150, that's going to go between the 90 and the 180. The 150 is a little bit closer to the 180 than it is to 90, which means that the angle will be drawn like this. We're just looking for a rough sketch. So that right there would be your 150, but I'm going to label it 5 pi over 6, since that was what the original angle was. So that's going to be over here. And again, how I knew that what quadrant to draw it in, it's because this is 180 and this is 90 as talked about previously, which means that your angle is going to have to go there. Also, what I know is it's going to be in, for the quadrant, it'd be quadrant number 2 is where that would be the answer to the second question. So again, they want to indicate what quadrant each angle lies in. So in this case, it's going to be quadrant number 2. Let's look at a negative 135. So we can just keep that in terms of degrees. Now, if you're going in the negative direction, you start with 0 here, and then it's going to go down here, negative 90, negative 180, negative 270, and then negative 360 here. So if you're going to go this direction, remember you're going clockwise if you have a negative angle. So this is how you can tell what quadrant it's going to be in. We go 0, we go down this way, negative 90. Then a negative 135 will end up here. It's between negative 90 and negative 180. So when you draw that, it's going to end up here in the third quadrant. So right there, that would be negative 135. And that's how you know where to draw it. If it's negative angles, then this is what all the different quadrants are labeled as. However, you're still going to have quadrant 1, 2, 3, and 4. So that's not going to change. Even though you have negative angles and you're kind of going around this way, quadrant 1, 2, 3, 4, that stays the same. So therefore this one, if it asks for what quadrant it's in, you would put quadrant 3 for this one. Now let's do 8 pi over 3. Now 8 pi over 3, again, it's another one that's in radians. So I'm going to change it over into degrees by doing 180 over pi. The pi's, those are going to cancel out. 3 goes into 180 60 times. And if we multiply it, we get 480 degrees. Alright, now 480, that's an angle that's more than 360. So what I have to do is I have to figure out how much more it goes beyond 360. I know I'm going to go around once and make that spiral that we talked about earlier, but then I got to find out the extra amount that I go. So I'm going to do 480, subtract 360, and if I do that, I get 120 degrees left over, which means it's going to go all the way around once, 360, then it's going to go a little bit more to 120. So let's take a look at that here, drawing it in standard position. Again, it's still measured from the positive x-axis because it says standard position. We're going to go around once. That right there represents 360 degrees. But I have to go more, I have to go 120. So if you're, 120 will allow us to be in this quadrant. It's between 90 and 180, but 120 is a little bit closer this time to the 90, and so this is what that would look like drawn in standard position. I would label this 8 pi over 3. So it goes around once to here, and it'll go around a little bit more. That would finish it, so this would be what your angle looks like in standard position there. And we notice that it's going to be in quadrant number 2. So once again, this one's going to have quadrant 2 as the answer because it's right here. It's between 90 and 180. That's what qualifies that for quadrant 2.